Assignment 6 and quiz 5, Tuesday after that. Last time we did the module. Yeah. Well, at least we got the module. And module fail, let's see what module. Like that here. Because module this. The module current module. I've got essentially these are the ones that get loaded by the first one is modules for how we're modules. So let's see here. Talk about what modules are. They're pretty straightforward. What's the downside of it? Somebody else has to. You're working with a person at another institution, access to your cluster. If you don't have that module, you and they don't put this software. The good news about modules is second, you've got conduct. Who has used this one before? Some capacity. You then so y'all know yeah. So yeah, intro Python, most intro bioinformatics, they're talking it's super complex. Yeah, it's kind of like it's almost like the modules that you're setting up. And so conduct lets us build an entire environment. What is the environment, all that context and all the dependency mapping that is not the how to do X, Y, Z, the computers see the better. So let's just kind of build one of those. What's the downside? It does, it's a dog, yeah, so it does give us stuff to have. We can get around that. Sometimes it suffers from the exact same problem that modules have, which is somebody else had to do. So what's going on is that there's these different channels out there. There's like the Biocomputing channel, on the forest channel, the new map channel, and all these different repositories. And those are run by people that install the software and use like all the hardware that works. You can get it on the recipes. That. So the last time that somebody was in and updated that on the recipe is the last version of the update. If nobody has bothered to go in and make on the recipe for that software, you can't install it. So this solves some problems because we can just like load up Conda. Actually, as a module, it's a module. And then we can Conda install this other suite of packages. There's a lot of them there, but not everything. Some of them out of date. Every now and then you find them to broken. Bad job. Package. If there's oversight for that, so they have to pass checks to get into like the file or repository or not for everybody to play. And you're out of luck. If there's software you want to use that doesn't have the Conda module, then you're out of luck. So that brings us to the most annoying way. Use the way that we manipulate this. We download the binary. Build it locally. So we got a little table of like compare and contrast. Who manages it? System admin manage. Content environments. You. Well, this should come with a little caveat. You get to decide which Conda stuff you want to install, but only pick them up there. So, also the Conda channels. If you want actual control, you have to build it yourself. Where is it installed? This matters. Where things are in the computer matters. Most of all, it's the most common error we get. So if you load a module, add them to decide where that module is. So let's do one. Oh, look at this. New module, let's drop. There's not even six. But let's load those types too. Module, load, tie, and then capture it all later. Now, why can't you just say module load tie too? What's this? Wow. Stop. They don't, but they're just making sure that we know what version it is. So they've added this 2.5 link to it. That's that version of it. This is a line unit software. So what's this? You can see. I've seen that a lot. Oh, good guess. It's not really. GCC is a compiler. Turns C and C++. So they're saying, hey, we got Rudy. we compiled it using this version of PCC. This is my fifth HPC I've worked with, and the only time that I've seen that is this. So it depends on your system you're using, but this one they're like letting us know how it's compiled and how many inputs. All right, so I'm gonna get into that module of butterfly 2. Done. Now I should be able to say butterfly 2. And it's working. How do I find out where it got installed? Which I think they probably do it. And seven, that it's a mystery. Not gonna put it up. All right, that's where it is. User local Bora. I think that is on both types. That's a module. Where it gets installed to depend on the pattern. Okay. You've got a module, it's just module load. That's very often. If you've got a conda module, you first have to get conda, and then say conda activate, you fire. So then if you install this locally yourself, you have to keep track of where you installed it. You've got to be able to like point your.
Don't the module like to sort of that also related to
In this case, yeah. So the whole thing, yeah. So whatever they call it, here it's tool GCC version.
so that's just like a specific.
That specific one.
Like if you only do or
It might, actually. We could probably just say module load butterfly 2, but be ready for there to be 2 or 3 versions of butterfly 2. That's right. So in general, I usually put take it out to. There's only one or two lately, that's popular. So availability, it depends on you basically emailing the admins and saying, hey, do you remember that I asked for this module? Well, assignment 6 in my class is going to be this module. Oh yeah, we're so sorry. And 2 days later, shuts up. Why? In the condo, you've got access to thousands of packages. About what it is you're doing yourself, you can find a GitHub repository. You have that software. Any other question? Maybe about setting up. This is important because when we submit a job to a cluster, it doesn't know it's software. It doesn't know where it is. It's never heard of it. So you have to tell it everything. That basically, here's the environment you're going to work. Here's how you get around stuff. You're find things. Now, so being able to set up that environment right at the top of our it's called a starting down cluster. You give it instructions on here's how much memory I want, here's where I want to put it on, here's memory. please put your mark. Then it comes around and gives you your time and starts running with it. Top to bottom, there's stuff they're setting up. So very often we do the load, and it's to activate this environment down here. The way around all of that is the fourth way. Tools like Docker are entire shipping containers, the entire environment. By entire, we mean everything. So like what?
Why am I saying we downloaded the OS and everything?
Even an operating system.
Yeah, I mean, we literally download every software. So it's like we how we need it to happen.
But with everything.
Yeah,
I mean, you're making a virtual computer. So it's got the operating system, it's got the app, it's got like all the software, it's got all the libraries, that software. It's got its own architecture. We can like take this and just set up a virtual computer that stands on the. That's what Docker is. This is super powerful for sharing software with people. They don't have to install it. It's just you're giving them a computer that runs your pipeline. It's got the pipeline scripts in there. But it's also really kind of, it's got a steep learning curve. You've done it. How was it?
I think for the beginning, I thought it was great, like there's like already configured and you could download things. We picked out you get this, you know, already you already be ready. I don't know what confusing the most was like when I first downloaded it, I was running it all on it. And then when I tried putting it on the APSC, the fun button, like it was like the Mac architecture, Docker version when it run on the APSC architecture. And I like didn't know what that meant. I was just kept on trying to run it over and over again. And then I just kept on making my Docker images on the computer, and then I like took up like 30 gigabytes. And then like I didn't know how to delete it, and so like my computer just started crashing, and I had like zero storage. Yeah.
This tragic tale y'all just heard is that's normal. That's what it's like working with Docker all the time. You get a little bit better at it, but then
It doesn't show up when you do it's just some data. Like
yeah, because it's a fake computer.
Yeah, it's like if I open my Mac, I'm like, why do I only have 2 like gigabytes left in my hard drive? It'll just say 100 gigabytes of system data.
Yeah,
I don't know what system data is.
system data is like Mac OS. Yeah, so you've got like 30 copies of your entire computer sitting taking in your computer, which is ridiculous. Okay. And then there's also this idea that it makes it totally portable and like it's great. So let's say we got it working. It's 30 times faster. Got our Docker image. Just give that. Here's the Docker image. You know, like that's the next thing that happens. What's Docker? I just we want to my body to be super ready for it. Then they've got to install the software. Read that. That's not super easy. And if they're doing it on HPC, we got to worry about the HPC architecture. Install kind of it's into the next there. So it solves all these problems by having this portable entire computer all the way to ready to go. But it's actually kind of hard to use that. You really know what you're doing. So we're skipping it this class because getting it to learn almost never works. This is really great for enterprise level software. So we've got especially proprietary software, you can put the Docker in those. Okay, so Oxford Manifold is offering sequences. If you want to use their equipment, you have to download their doctor and then you figure out doctor and doctor. It's actually kind of a nightmare, but have them tired of just. That's how they get you because it's like you can buy a little portable DNA sequencer that plugs in a USB drive to sequence its DNA, which is so cool. It's $1,000. Love it. $1,000. Then you gotta buy the kit. Plug in. Some pilot ship. That's got a 3-month expiration date. You know, but it's super cool. Problem is that it takes over the computer. Like it's a proprietary software. So that's Docker. That's why I'm like, your software firm makes sense. That's mostly where you use it. All right, so you believe it or not, you've already set up an environment to run Botai 2. Includes that. So that instruction would go at the top of the script. If your script required Botai 2 in this HPC, one of the top lines is to be like, hey, load Botai 2. That's super great. But let's try a condo. And this is the weird part, is we're actually gonna have to use a module to get condo. Then use condo. Module load menu for security. Module load menu for security. Nope, I've been here. Oh, I spelled it wrong. Me. Okay.
So what is?
I don't like that it's a bug and when we write the path, the way that he designed for. It in reality, I wasn't decided that, but I imagine a lot of the thinking is the same way a lot of Python active development has people are big dominant, but just stay over the computer. It's not bad assumption. People are a bit dumb in computers, and so they're just like, here's what we're gonna do, we're enforcing it. Okay, but you guys aren't dumb in computers, but you know what path is, and so you don't bother. This is the part I don't like about combat. And you get on ChatGPT, that's what they tell you to do, because that's what the forms trained it to say. Don't do that. If you do, then you do it. Listen to it. Okay, so exec bash is like closing your other shell. It's told me to do. What happened to my prompt? Here it was before. Here it is after. Now, every single time I log into the HPC on the took over. How do you take over somebody's login file? So if I cat home dot bash RC, see down here, I ran conda and then added conda initialize contents within this block are managed by conda. Alright, so it's setting up everything. It's running this conda setup. It's exporting my path now has this path. And so then it's run conda setup. So every time I log in, my bash.rc file gets run. So to undo the damage that conda has done, right, I'm gonna use nano bash.rc, page down to this, and then kill it. Now I can exec bash out of the base. When we started this semester and I was walking around looking at all your terminals, a lot of you had that base. You still. Yeah, and that's okay. That's because you run conda. So if you want to undo that damage, go into your .bash.rc, just delete this whole chunk right there. You can still use conda, and we're going to show you how to run conda. So conda and Nit was kind of a dummy proof thing where I'm guessing within developers, like people don't even know what a bash.rc file is. So, well, let's make them use conda forever. Every time they open the terminal, they're going to keep running conda back up. And what's the problem with that? Taking away your choice. And processes that run, we're going to have conda in there, like going on in the background, possibly without nothing. And that can conflict with other stuff that we're trying to run.
If you like, you open something in the conda, I use conda for the you know, it's like, you're gonna look at the video environment, right? Really happening. Is there like, you also just notice that like, with always like different stuff, where it's like you down something, it's just like always, yes, conda also.
When you, yeah, so you can say conda and computer.
So it's like, it's like we're saying, like, you could just have like all kinds of concepts, and then regarding.
Oh, yeah, so you can just add some of the lines we'll see today, like on the day, whatever. Yeah, you could put that in your .bash.rc. So every time you log in, you turn on the got that on that mark. What do you do that? There are a number of reasons. One is what kind of environment we can make like evidence for the tenant. So you may need to apply that was this whole other file or then it's possible. So you can't have some software in this. So by loading it every time. So, like for my workflow, there's some software that really is just so much easier to use Conda than for me to install it myself. That if I want to do base calling, like those Sanger sequencing, I've got a Conda environment just for that. Base calling. find the pages, I load it up. But I'm gonna write that about it. But we'll see how that works in just a second. Yes, for your personal computer on the HPC, yes. Yeah. So that's what Conda init does, is it rewrites your backup scene. Follow me so far? So we're gonna skip that part. But the next line you'll see, and this is just like what you're gonna see from ChatGPT. Oh, great, you wanna run BBMap. You can come in and then create an environment. Named BBMap and will contain BBMap software. And then to access the BBMap software, we say conduct activate that BBMap environment. So we're going to do this, but we want to do it without first having one. So we're creating, we need the -y. It says yes, yeah, because it's going to ask you all this. You want to proceed, you want to install that, then you have to say yes when you want. So maybe just like auto says yes to that. The -n is the name of the environment that you're loading. So you can call that whatever you want. Best practice, what I've seen is the name of the software that you're interested in. Some designation, fire, -n. And then you want to tell it what software to put in that environment. What happens behind the scenes is that Conda looks in some channels, like Conda Forge, what's Bioconda, like it goes online essentially. So it's like, hey, I'm looking for the BBMap software. Do you have it available? It's kind of looks like a path. It's just the path is the channel says, yes, I do. I have that. Would you like to install it? Then yeah, I'm making an environment. I'm saying yes to everything. My environment's going to be named BBMap N, and I would like that software. You know, it goes online, it searches, it finds that software, and creates an environment. Don't have the internet plugging, unconfigured.
Right. Okay. So you have.
Well, they're not ready to line. I think so. No. This is what this is an example of like if you said I want to install a BBMap on the environment, ChatGPT will give you the help on the but this is a cautionary tale. Don't do it this way. So Conda and Yet, it really does assume you're the only user. It tries to make Conda universal, like take over your entire system. You run this once, you are now running a Conda terminal forever. Why wouldn't you want that? I think it's a bit presumptuous of them, but okay. Because usually I don't want to. So we've got Conda loaded. How did we load it? Module load many force 3. Okay, so it's loaded, so we should be able to say which Conda. Give me a module list. Let's see if many force 3. So you have to do module load many force 3. Oh. Conda is part of many force 3. All right. Many force is the modern. When we loaded that module, it gave us Conda. We could have installed Conda ourselves. Like downloading the binary and unpacking it, filing it, in spot and adding it to our path. But man, it's just a lot nicer to say a module load than free. Within the suite anyway. Module load won't work on your personal computer. Okay. So when we say which Conda, that takes us here. Or shows us that spot. Cool, so that's the directions to get to the Conda. Okay. What we're looking for is this conda.sh file. Conda init runs that file automatically every time you start up, and it runs some extra stuff that takes over and like rewrites your app and cuts it. We don't want that. We just want to run conda.sh. That's different from Conda itself. This is weird. Here's what I'm going to do. I'm going to go in where mini footage. I'm going to copy that. Let's see. We're going to try to find that copy. So I look around. Okay. So when I said module load mini source 3, basically just like populated this directory for us and put it in a path so that we can access it. And then I'm going to go into bin. Binaries, these are all the example files. Look, it gave us pip and pip3 and OpenSSL and Mamba and whatever KVNO it is. It gives us like all this different stuff. And there's Conda. Right? So when we said which Conda, I found it right there. It gave us all this other stuff. I mean, that's not what we're looking for. We're looking for a file called conda.sh. So I'm going to go back up one. So we back up into the mini storage. Right. Okay, where is it? How? Here's another way of phrasing the question. How could I find a file? How is it possible to find a file? It didn't work. Okay. Find. You've seen it once, but let's go through it. Find. You want to give it a directory to look in. And then we'll find everything. That's the basics. So if I say find /, it's going to find every file and every directory starting here, which is where the recording. Whoa, yeah. How many things was that? Where you count L? Found 26,268 files and folders. So all you got to do is search through all of those. You can find conda.sh. Well, luckily, find has some other flags. So we can like customize how it looks for things. So it's got like a size flag. And so we can say greater than 50 megabytes. Found nothing. Greater than 5, maybe? Yeah. So there, it found all the files that are larger than 5 megabytes. That's good. So the size works that way. Name. You can find things with a specific name, and this works with wildcards. So in quotes, you say find a file name or a directory named conda.sh. Correct. So it's here in etc. Divided by b on the dot. On the dot star. Let's find the on the dot phi, dot that, on the dot this. So find gives us a lot of ways to get the things based on their name, their size, all that kind of stuff. We look into the documentation there. You can see there's a lot of stuff that we find. So let's see. CV is etc. Goes around using profile.pd. Look around, and there it is. Sure enough, on the dot. All of that is just to show you what this command is. Kind of hard to read this, but like in math, we're going to start in innermost parentheses here, and we're going to evaluate this dollar which condo, which stands to the left. Yep. So if I echo it, I'm going to take this. That's where it started. And then it's going to do the dollar year name. Which one? Copy that. It's that process substitution again. So this is the directory name of the result. This line makes sense. Evaluating where comment is found. And from that, we're getting directly. That's connected to this band. But remember, we actually had to go and find it backwards to set it up. We need to go back another one. So we're doing two directory names. So the directory name of that directory name. Okay, so that gives us essentially like the long way of just designating up. Why didn't you see one or the others? You like the other ones really long, but this one works. So that stuff good. Now we've got it. But I'm not. We're gonna stick with the lesson. I'll do it in my free time. Put it on. Okay. So this right here is a transportable way of getting this directly. Why do I do it out there? It'll work on any HPC. Even if it's not being cycled. Even if they're running a different version of the first grade. So that's why this is happening. So that, and then it's set up the comment that it's just the rest of the path. So if I run this whole line here. That is the path. I'm going to show us split. We're doing all of this to get around the path of the equation. So we want to run that. We can do that with the system. We're going to source the back on the file right there. So we already run this line. Let's run this one. That too. Man, this shell script. I want to see what that shell script has in it. It's this. So it exported some environmental variables for us temporarily, not permanently. It's going to run them, and it gives us the ability to say on to activate. Right now we have Conda, but it hasn't been set up on our system, and so running the shell script sets it up so that now it knows how to talk to the internet, where to put files, where to download files. So there, if I'm going to use Conda on an HPC that has many ports free in the module, this is how I would do it, those two modules. So I run those right at the top of my script. Now I've got Conda. Now we're able to run Conda fields. So if you try running it, it's like can't find it. Now it should be able to.
I don't even think like needs like something like select it.
There we go. This.
Yeah.
So you notice that it's kind of slow. Slow process. Mom mode is creating faster. And then assignment is my mom mode, it's the exact same thing. You just change out whether it's on to create or mom mode. It's just faster.
What's it say seven? Yeah.
If you get a solving environment fail,
But I'm gonna get to like that.
I don't know. Your current channel is condo storage. Okay, mine worked. And let's see why. That's not expected. There. Interesting. So the bound line within find it can use says that your channels are going to be just on the board. Right over I have Biocomputing also. So that's where I'm using that is Biocomputing. It's not. What's happening is it's gonna, these are just online channels. It's gonna look in first guide for me. Then it's gonna look in Biocomputing and then on the forge. Well, all we gotta do then is tell Conga to look on the forge. I'm gonna hit up here. Oops. Not Biocomputing. The dash C is channel. A website. Yeah, think of it like a TV channel. We have these available programs. So dash C will say like, hey, I want you to definitely look at the Biocomputing. If you're not sure where it is, you can do that, and then you can say the forge, the second channel, the third channel, first sky. So that should work for you. We have the dash C Biocomputing. I'd be like that's for you, but I don't know. Everybody have. Oh, for new research, okay, yeah. Yeah. You're in that job. So, I'm gonna add a dash B here. 500.
So you have to do that, it's about the that is going to.
You only have to create it once.
It's there.
Yeah, it's there, it lives in your like home directory as the environment. Called meeting out and you can go find it. If you want to, but you don't that one perfectly clear. Afterwards, it's gonna say afterwards. Now, solve the 502 whatever. So this line, we're creating the environment, again, that's a one-time thing. So in a script that you submit, if it's the first time you've ever submitted it, you can do that. The second time you submit, if it finds it, it won't overwrite it. And so it's safe for you to. Like that's what we're doing. It's like, it's okay. I'm gonna run this again. To confirm to myself. Say. So I've already created beacon map and do it again. Crazy. Yeah, I thought you had to say forest.
We are just.
Yeah, but maybe it just.
Is that just like it opening?
Yeah, like it's just like. It went a lot faster.
It did.
So I think it looked like it. So that's fine. So once that's run, now you can say on the activate the name of that environment. What did it do to my it lets you know that you're in on the environment. That's what that parentheses base was on your computer before. It's letting you know that hey, you're in the base content environment. It doesn't tell you that when you log in, it doesn't give you a helpful message that says, see that base down there? That means that you're running a computer you don't understand. Right? It'd be great if they didn't say that. We can go ahead and add that with a line echo. If you see base, come delete me. But now it's saying I'm in BBMap and what has that done? Put me into a separate little environment that knows what BBMap software is and knows where it is. So I can just say BBMap and then hit tab a couple of times. And look, give me some options. In fact, if I just hit BB and hit tab a couple of times, see that got this whole bioinformatics software suite available to us. Called BBMap or BB tools. But the one we want to use today is bbmap.sh. Look at that. I can just run it. I don't have to append a prefix to the front. I don't have to add it to my path or anything. Conda is taking care of that because I am in bbmap. So now I can run this bbmap software with a crap ton of bots. Only works while you're inside of Slack.
Is that what you like? For example,
For meeting that,
just so like any kind of
whatever, like the first flag is just fly. Okay, here's the guide. Written by Brian Bushnell. It's nice. So we've got some info about this. You can get online. This dude is like still active. We're the Joint Genome Institute. And he'll actually answer your question personally and thoroughly, and without insulting you. He's rare breath of fresh air. Some people that run software feel like they're having this real trouble. They just write back like, you suck. It's really that's terrible. The Brian Bushnell is super great. He's active on the forums. He wants people to use his software. He's a government employee, so like furloughed right now. But so don't expect an email from him anytime soon. First of the Joint Genome Institute and has written this entire suite of software for mathematics. We are right now just reading one of those. You can see that it does all stuff. Yes. Not fun. Yeah. Well, I'll let him get away with it. And say it's like a vision move. So it's awesome. Yeah. Right. So we got the website with the documentation. Look, a forum link. So if you got any problems, post here. You actually answer them. There. A lot of this software was written by a grad student who like moved on and got a job and decided like I don't want to go with that anymore. I got my degree. So it's just kind of a black hole. This one's actively. Okay, so we run bbmap.sh and it just says, hey, you didn't do this right. Here's how you need it. Go ahead and figure it out. But we're in a bbmap environment and that can make things confusing. So if you want to get out of it, you say conda deactivate. And I just say conda deactivate again. Yep. So that took us out of bbmap, but left us in base conda. We can have it deactivate basic. Here's how I would do it. In one line, on the deactivate and only run if the other thing on the left finishes correctly, then run thing on the left. So I would just deactivate. There's outlets on this side. Your type. Okay, so we've done everything except operative. There there's more esoteric ways than we basically, other than the ones. We build stuff ourselves, add it to our cloud, we use the module. Like mouse, we hate the mouse, we got reproducibility. Like modules, I like modules, it's my favorite. Like it is there, it's great. Yeah,
Last time I was using, like sending, like, ready, we have this.
I mean, they did it, right?
Yeah.
Yeah, every time. That's literally their job, like they're getting paid for that, and they don't mind, obviously. They get a backlog until they take a few days, but. If you've got an HPC and it's got a team of people and you're running it, I think it's awesome. But the big thing with that. But it's not portable. You get an HPC, unless you ask for that, hey, here's the version of it. My least favorite is Conda, actually, because how tricky you have to be to use it. But once you've got this pattern, it just kind of works every time. And so the top of your script can just be like, hey, it doesn't matter what HPC you're on. It's set up profile d conda.show is how conda works. And so you just need to find where conda is on the computer, the basic record of that. In this case, it can be storage. So I don't like that you have to kind of trade it to use it correctly, but it's not hard that much. It's just like a matter of have to run that when you can say contact. Then you have to remember to activate that button. So now that I have my PB map environment built, I actually don't need to do this stuff up at the top at all. That was just kind of get it set up. So at any point now, on the HPC, I can just on the activate on PB map. Dash D to give us an inversion. Version 39.13. Back in the PB map environment. I want out, I'm going to pump deactivate again, deactivate again. Out.
So it's not just like positive version of the
Search for it unless you do that dash gate. So let me activate the map. So PB map. .sa. You just run BBMap.show. It gives you a little usage. There it is. Back there. Be on the lookout if you're using Conda. Be on the lookout for that. That's when you see it, you should think, oh crap, you need Conda. That's the version of Conda. This was the version. Well, Let's do something. We've got a little script right here. This will give you some files. I would do this inside of lesson 6. We're gonna get E. coli, BL21, E3. That literally is the genome of the E. coli, that particular strain. It's also going to give us lambda reads. This familiar with lambda page? What is it? Okay, yeah, it's a specific kind of phage, and it's kind of famous as like a good biological system because it's a phage that incorporates its DNA into the host genome. And it's kind of evil and tricky because it won't activate and kill the host until an environmental trigger. And so it's like a latent poison sitting in the genome of the host. It's super like freaky to me to think about how mean biology is. Beautiful. And evolution has given us all this great stuff, like wheat, wine, humans. But it also has given us land of age. Works through murder. It's an artist with invisible, selective murder. It bothers me mentally about that. Land of age, here it is. So we've got a sequence of the genome of E. coli, and we've got the sequence of a bunch of lambda-phage genes. Not exactly a single genome fragment. We're going to use BBMAP to look for lambda-phage signatures in the E. coli genome. BBMAP, Brian Bushnell's mapping software, map shortening technologies. So we're going to look through those patterns. Okay, so this will be our script. And this will be just the download script. So I need to get back to my biocomputing lessons. I'm going to make a directory scripts. Go into scripts. And I'm going to nano download data. Paste it in. Real simple download script. It gets the file, extracts it, and then it's ready to add. Exit. Chmod plus X. Out. Well, I kind of don't like this because they downloaded that into my script directory. So remove them. Star dot fast star. That should work, right? Every file that begins with anything that's dot fast ends with whatever. Cool. I'm going to go back up. I'm going to make a directory for data. Go into data. And then how do I run download script from here? I got to go back into scripts. Develop the relative path to get there. Cool. So head start, we're getting the first X lines of each of these. So we've got the E. coli genome complete sequence. There's the NCBI section number, E. coli, three. And then we've got some lambda reads. These are just short reads from the faster. Neat. Okay, so that's our first script. Now we want to use BB stats to inspect them. Can't do it unless you've got BB map or BB stats show available. So go ahead and make it available. Very built environment. Activate.
You don't have the solution mechanism.
No.
So I get
Oh, every time you log in, yeah.
everything you want in here. Is it a smart $5 when I service one?
But you can't do that unless you've done module or it's free. So if you wanted to, you could add module or it's free and then source that on the drop shop. You could add those two lines to your FFA and reload it for you. But then if you submit a job to the cluster, it doesn't know about that. It's not you. So you have to add those to your cluster script also. That's just right. So I say on the activate UV map environment. Cool. So now I can say UV stats show star. It doesn't like star. Likes neat. So this is a scaffold saying you have one. Basically one lead. If this was a human genome, I'm just scaffold. Need distinct expression of DNA or human things. Let me see. 46 is on the right path, but 23. And then mitochondria. So you get 24. In this case, this is a bacteria. It doesn't have a bunch of chromosomes. It's got one circular genome. So this is saying like, hey, we've got a full genome here. If this said 5, that means we've got 5 stretched of DNA. We have to put them all together. Like, maybe that would be plasmids. So this is telling us we've got one chromosome present in here, and it's this long. That's the whole genome of the coli. Right. If I do the same thing on lambda reads, I've got 10,000 separate reads in there. All of them are about 100 bases. Got the breakdown of ACG and T. So that's that. And then here's how you would map it. UVMap.show. We can say that because we're in a UVMap environment. We're going to give it the reference genome. Notice there's no space equal. Ref equals this file. The input reads the things that we're going to be looking with of the lambda reads, like theory or reference. The output file. And then we're saying no, this is true, don't save the index to this, like this. And then if there's multiple matches, we're saying ambiguous, pick the best one. And then we're saying, all right, you want the minimum percent identity to be at least 90%, you need to consider this a match. And you use other things. So I take this code and I run it. Oh, it didn't like when I split it up along the lines. Oh, it's because that, hate that, got it. So, got it. Yeah, we can put it in script. Yeah, it's the comments, it's not part of it. I did run it in script before, so. I'll just make a script. Run the thing, right. The bank. And bash. Random. So odd plus x, another thing about still doesn't like it. And I'll run thing about okay, fine. I'll just throw it all on the line. That'd be that way.
Spaces in between.
Space in between. I'm just running it in the data directory, so yeah. Man, 5.2 seconds. There's just a lot of information about what was going on there. So in Honda, I don't need to be in my DMF Honda environment anymore. So I say, what? Look, and output file. So this would be a link in the pipeline. You better believe that you're going to be running and keeping that in a lot of the time. Did that all kind of stuff, that really fast, really well. And anytime you want to match some DNA up with others, with the pattern matching, this is like one that does. Cool, it gave us our output that we described, mapping.sam. I'm gonna take a look at that. Beautiful, right? Chaos. Let's see. If we can make it. No. So it is a tab format. It's not really good enough to see that. So it's like an almost unreadable horrible kind of file from that, but it's very handy. It's got tools that will work with this file for the next step. Okay, so if you want to know about what that file looks like, here it is. It did the Googling for you and stuck it here. And so it tells you every single read that was in your query, where it matched up, where it started, where it ended, how good of a match it was, a bunch of information. read sequence and quality score. So we can go through and find things that did match or didn't to see, got good matches. Of course, if you want to do that, it's the same tools program, it's the same products. So you could make yourself an environment that had either map and same tools in it, just get ready to roll with it. Have a fun break. Your assignment 6 is doing what we just did, but with another program called Fly. The quiz is you get some strips, make a pipeline. Right, pipeline's ready. But no, not in 5 minutes. Am I going to force you to write 3 sets of script and a pipeline? It'll be a bold choice. I'll do it if you want.
I don't.
All right.
You never just go.
Yeah, it's